Well, good afternoon. Here we have our second work example, second set of work examples for belt and pulleys. And remember, please do amend what it is wrong that I did wrongly on the work examples 1. And I have explained how you do it, okay? How to amend it. Now, on the second part of your work examples, okay, so this is the first problem. Two pulleys, one is 450 mm diameter and the other one is 200 mm diameter, are on parallel shafts, which is 1.95 meter apart. So the center to center distance here from one pulley to the next pulley is actually 1.95 meter apart, and they are connected by a cross belt. So this is a cross belt drive. This is a cross belt drive, and when you look at it, now, how do we consider T1 and T2, tight side and slack side? So again, you have to look at the direction of rotation of the driving pulley. So when this, or the driven pulley, so when you look at this, now, so actually it is rotating in the clockwise direction. So that means that you will be exerting a pull here at this point. My laser pointer here, you will be exerting a pull here at this point. So this side of the belt will be tight side, and then deliver it to the other side here. This should be your slack side. Okay, so it again depends on the direction of rotation of the pulley, please. Now the center to center distance here, from the center of this pulley to the center of the next pulley, here is 1.95 meter apart. So hopefully I didn't make any mistake here. So okay, and are connected by a cross belt. He's my student, sorry. Now find the length of the belt required and the angle of contact between the belt and each pulley. Find the length. So this is a formula that I have given in the class. So this is to measure the length of the belt. Now, the difference between open belt and cross belt is this sign here. So if this is a cross belt, then this should be a plus. If this is an open belt, then usually this is a minus sign. So how we got this formula? That you have to refer to some references. Actually, you can use binomial series or the Maclaurin series to prove this belt length formula. Okay, so substituting the R1 and the R2, make sure it is radius. Okay, make sure it is radius. So 450, half of it is 0.225 into meter. Actually, you can keep this as millimeter as well. So 0.1, that is half of this. So your R1 and R2. The X is your center to center distance. That is from here to here. And then your 2x. Okay. So from this, you can work out the length of the belt of 4.98 meter. That is correct. Now, and then your angle of wrap. Sorry, this is not your angle of wrap yet. This is simply the angle between this point here to this point here. So this is taken as theta, and which is not your angle of wrap yet. Okay, your angle of wrap should be this side here. Remember, angle of wrap from the word wrap, wrapping. Okay, so that means the section where the belt is in contact with the pulley. So that angle, that particular angle, we call it angle of wrap. So that is this part here. Sorry, and for this, it should be somewhere around here. So this angle, this angle here, somewhere around here. Okay, and then we have taken it as alpha. Anyway, this should be 360 degree, correct? So you work out your theta first, and this is a plus, not a minus sign. Okay, this is correct. So you will have now. Earlier in the notes, I have shown you how we have a plus sign here. Okay, so the theta you found that is 160.81 degree. And then to find out the angle, the actual angle of lap, now geometrically, alpha 1 and alpha 2 should be the same. Okay, please, your geometry. So that is taken as 360 degree minus the whole angle theta, not the half angle there. The whole angle theta, that is 160.81. So you get your angle of wrap for a cross belt drive. For this case, is 199.19 degree. So you can convert this to radian as well, please. do so. So this is how it works for your cross belt. So I hope these animations do really helps you. Now, then you have your diameter, your speed, then you can find out your omega 1, that is 20.94 radians per second, again, belt speed. So after seeing this formula for a few times, I think you should be able to remember by now. That is the belt speed, your radius. Now, this radius and this speed, now the belt speed, if let's say you take R1 and omega 1, make sure this is R1 and this is omega 1. And don't put R1 and then this is omega 2. Then you will get a wrong answer. So make sure this is R1. If you consider R1, that this should be omega 1. Or if this is R2, then this should be omega 2. Okay, so you actually get a same belt speed of 4.71. No matter whether you refer to 1 or 2, that means the driver or the driven. So you get a belt speed of 4.7 meter per second. So again, that is less than 10 meter per second. Unfortunately, earlier we have one question that we can work on TC, but that one I have my own mistake there, so we have already ignored. But then you have to revert that, please. Okay. So angle of lap 160 over 180 convert to radians. Now belt tension ratio. Okay, then you have your T2, then you can find out your power. Follow that? Okay, hopefully you will be able to understand this first example of the second part. Now, if you can't, please repeat. Okay, you need to repeat some of the podcasts that I have made in order to understand. The purpose of the podcast is for you as a weaker memories person to view as many times as you can remember. So it is repetitive, so you can repeat and repeat again. Now, question 5 here. Now, by finishing this, I wish that you can really start doing your work on belt and pulleys. Now, a shaft rotating at 200 RPM drives another shaft at 300 RPM. Again, 2 speed and 1 power transmitted 6 kilowatt through the belt. The belt is 100 mm wide and 10 mm thickness. So the area, cross-sectional area is given. Okay, now the distance between the shaft is 4 meter. The smaller pulley is 0.5 meter in diameter. Calculate the stress in the belt. Now, this case, in this question here, they ask you to calculate the stress. And we know that stress is equal to force over area. So the only force that we have in belt and pulley is the T1 and T2, or the TC. So here, usually if we were to refer to the stress, okay, usually we will take the maximum tensile force, that is T1, divided by the cross-sectional area of the belt. Now, if it is an open belt drive, second case is when it is a cross belt drive. Okay, so this question here, you have to really look at it. Okay, you have to really look at it carefully, okay? So N1 is 200, N2 is 300, power is 6 kilowatt, is 100 mm width and 10 mm thickness. X is 4 meter. The diameter of D2 is the smaller pulley here, 0.5 meter, and we have to work out the stress for both the case A and B. So based on the belt speed ratio, based on the speed ratio between diameter and speed here, so this is correct, 1 to 2, and this side should be 2 to 1, because it is always inverse proportional. So you have D1 as 0.75 meter. Then you can find out the angle of lap straight away. That is 176.42. That means you can use this for open belt drive, which is blindness. You don't have to work out this, okay? Then the next one, you have the speed 20.94, belt speed 7.85 meter per second. The angle of lap is 3.2. Okay, that is based on cross belt. So this is your cross belt angle of wrap, and this should be your open belt, okay, angle of wrap. So there are two different angle of wrap, okay? So belt tension, work out, okay, your T2, okay, and then the equation of T1 to T2 based on this, based on what you have here. So you can work out your T1, your T2 is 474.74. Okay, there is a slight mistake here, I think. Okay, so 2.61. So based on the power, oh, okay. So based on the power that is given, you work out your T2. Okay, so you have your T2, so you have your T1. So remember, you have to find the cross-sectional area. So this is in mm square, please. If it is in meter square, then your unit should be Newton per meter square. If it is in mm square, then this unit should be in mm square. So the stress, you have to take the maximum tension, tight side tension. So not the 474. Please don't take the 474, put it here. Okay, so it is always on the tight side tension. So you got your 1.24 Newton per meter square. Now, what you can do is you can also use your T2, put it in. T2 divided by cross-sectional area. So you check your stress. Check both the cases for your stress and see which one is more suitable, actually. Now, case B is for cross belt drive. So here, you have the angle of lap. That is 197.38. Yeah, because this is a plus. The earlier one is a minus. This is open belt drive. You have to be careful here. Open belt drive. Okay, so you use this angle. That means you should be using this angle. Okay, this part here is wrong. Okay, sorry. Again, this part here is wrong. This shouldn't be 3.2. This one should be based on this. 176.42 divided by 180 times pi. Okay, mistake here. So I'm a human too. Okay, I make mistake. You are also a human. Okay, so that is the angle of theta, and then find out the angle of rep. Take 360 minus the angle. So fortunately, I'm going through this again. If otherwise, we will be giving people wrong information. So angle of lap. Okay, so 3.44. So you work out the angle of lap. Okay, and then the ratio is T1 to T2 is 2.81. Power, to find out the T2, the given power is 6,000 watts or 6 kilowatt. Then you have your T1, you work out your T1, and then your T1, then your stress. Correct. Okay, so the only mistake here is the angle theta here for the open belt drive. The angle theta that you should have taken is based on this value, 176.42 over 180 times pi. It's not this value here, that is 183. Okay, so this whole lot of things here, this whole thing here, you can cancel it off. This one also you can cancel it off. For open belt drive, you need to consider 176.42. You see this minus sign here means it's for open belt drive. So that is your angle of rep. So convert it to radians and put it into this. It's not 3.2 anymore, and it's not 2.61 anymore, and it is not 474.74 anymore, and it is not 1239.4 anymore. So the cross belt, the cross sectional area is correct, and the stress is wrong also as well. So this part B here is okay. The whole thing is correct. So thank you very much, and see you all on the next slide. See you all on the next slide. Bye bye.